All right, today we're jumping into one of the biggest, most stubborn mysteries in all of physics, the quantum measurement problem. But the solution we're going to explore is pretty radical, because it doesn't come from more complicated physics. It actually comes from looking at the world in a completely different way.
It sounds like one of those late-night philosophical questions, right? But this question gets to the absolute heart of quantum mechanics. It makes us ask what the word real even means, and whether reality itself actually needs an audience to bother showing up.
So let's start with what I like to call a quantum ghost story. And honestly, that's not an exaggeration. For almost 100 years, this problem has haunted science. It's a genuine mystery about how the universe behaves when we're not watching it. Okay, so what is the problem exactly? Well, it goes like this. On the tiniest scales, particles like electrons don't seem to have definite properties, like a fixed location, until we actually go and measure them. Before we look, the electron is just a smear of possibilities, a wave of probabilities. But the moment we observe it, bam, it picks a spot. It's as if reality itself is holding its breath, just waiting for us to look. This isn't just me being dramatic. The physicist Heinz Pagels put it perfectly with this quote. It's not that we're just discovering where the electron was all along. No, our act of looking seems to literally snap its existence into place. Super weird, right? This whole idea was so bizarre, so out there, that Erwin Schrödinger himself came up with his famous cat-in-a-box experiment just to show how ridiculous it all sounded. A cat whose life depends on a quantum event would have to be both alive and dead at the same time, until you open the box. He meant it as a way to mock the idea, but it ended up being the perfect illustration of this crazy quantum puzzle. Okay, so we've got this massive, spooky problem in physics, but what if the answer isn't buried in some complex equation? What if it's all around us, in the eyes of other living things? Let's take a look from a totally new perspective. Just think about this for a second. You and I, we look at a flower and we see, well, a flower in all its vibrant color. But a bee sees something totally different on that exact same flower. A bee sees in ultraviolet, so it sees these incredible patterns, like landing strips, that are completely invisible to us. That's two different observers looking at the same object, but living in two totally different worlds. And that leads to the crucial question, doesn't it? I mean, if a dog's world is built on smells, and a bat's world is built on echoes, and our world is built on vision, which one is the real objective reality? The source material we're digging into today says that maybe there isn't one. Maybe that's the wrong question to even ask. See, our reality isn't something we just passively observe. It's something our bodies actively build. First, there's all this raw data out there, light, sound, chemicals. Then, our senses grab just a tiny fraction of all that input. Our brain processes those signals, and only then, at the end of that whole process, does an object become real to us inside our own personal sensory world. Okay, you with me? We've got this idea of constructed sensory worlds. Now, let's use that idea to finally solve that quantum ghost story we were talking about. This is where it all comes together. According to this way of thinking, all the confusion comes from how we define our most basic words. What we've always just called reality, as if it's the only one, is actually something much more specific. And here it is, the core idea. Reality, as you and I know it, isn't some universal objective thing out there. It's simply the world as constructed by the human sensory system. Our reality is a human reality, just like a bee's reality is a bee reality. So let's go back to that electron, that mysterious collapse of the wave function. It's not magic. It's not the particles suddenly popping into existence from nothing. It's just the moment that information about the particle enters the human sensory world for the very first time. Before we looked, it wasn't a ghost. It just didn't exist for us. And what's so powerful about this idea is how it just cleans everything up. It dissolves this strange wall that physics had to build between the weird quantum world and our normal, everyday world. Suddenly, you don't need two completely different sets of rules for the universe anymore. There's just one rule, and it's simple. For something to exist inside a particular world, it has to be perceived by whatever system builds that world. That goes for a tiny particle, this table in front of me, or a giant planet. But you might be thinking, what about our fancy scientific instruments? Aren't they showing us what's really real? Well, according to this theory, no. They're not magic windows. They're just extensions of our own senses. A particle detector is like another kind of eye, and that click you hear from a Geiger counter, that's just the sound a particle makes when it finally enters our world, translated into a form we can understand. So if you take this idea all the way, it forces you to step back and ask some pretty profound questions, not just about physics, but about the nature of the universe and our place in it. Okay, so let's boil this all down. What are the big takeaways here? First, reality isn't objective. It totally depends on who or what is doing the observing. That means there are millions, maybe billions of equally valid sensory worlds out there. And our view, the human view, even with all our cool science, is just one of many. We don't live in the universe, we live in a universe of views. And that, of course, leaves us with the ultimate question. If every reality, from a humans to a bees to a particle detectors, requires an observer, what's left when you take them all away? What does the universe really look like when absolutely no one is looking?